about 5 people come in a club, they give all their jackets to the bouncer. When they come out, what's the probability that each of them got a jacket? Second question, what's the probability that each of them got their own jacket? So what's the probability that each of them got a jacket? Well, 5 choose 5. That's 1, because everyone obviously got a jacket, because 5 people came in, 5 people came
Wait,
out.
5 choose 5?
Yeah, right, because they're 5
Right,
people.
that's 1.
But in this case, if you are saying what's the probability that each of them got their own jacket, then you're asking about a permutation. So you're asking 5 permute 5, which is now 120, which is 1 over 120 chance that each of them got their own jacket. Right. So like I like that.
That was a lot all at once. Can I ask some
mean,
questions?
Sorry, that's like a famous. I don't know if it's very famous. I guess
Famous
it's
to
famous
you,
in my
maybe.
probability class.
I've never heard of
In my
that.
probability class. It's like an idea to understand.
So you have a
combinations
situation,
versus
5 people.
permutations.
5 people have like put something somewhere, and then they come and pick up a random one.
Basically.
Okay. And everybody gets 1 jacket back. But you want to know what's the probability that they each got their own jacket.
Exactly.
Okay. And you're saying this is a 1 out of 120?
Because it would be, in this case, it would be 5 factorial, right? Because it would be a permutation in this case. Because each of their jackets, because the question, sorry, wasn't what's the probability that one of you will get your own jacket? I don't know if I ordered that correctly. The question was,
No, you
what's
said
the
everyone.
probability that each, yeah, exactly, everyone will get their own jacket. So in that case, what's the probability that this guy gets his jacket? 1 over 5. What's the probability that this guy gets his jacket and this guy gets his jacket? 1 over 5 times 1 over 4, because there are only 4 jackets left. And then times 1 over 3 times 1 over 2 times. So that's 1 over 120.
Okay. Interesting.
Right.
What do you think about the one where, what's the probability that you mentioned where someone gets their own jacket, but maybe not everybody?
Yeah, so in that case, that's a simple combination, right? Because in that case, you're just saying, okay, everyone, there are 5 people and there are 5 jackets.
Wait, no, this is more complicated. Because, like, what's the probability that at least one person gets their own jacket?
That's not what the question was, but you can make it more complicated with that, sure.
What was the question then?
So the first idea is basically what's the probability that each of them get a jacket? Because in a case where, let's say, 4 people come in with 5 jackets, there's actually a probability that not all of them do, right? Because like then 5 choose 4, because there are only 4 people. Or sorry, 4 people come in with 5 people come in with 4 jackets. Sorry, is what I meant. 5 people come in with 4 jackets.
Oh,
then
somebody's
not
gonna
everyone
be
will
cold.
have a jacket,
Okay.
right? Exactly. But in this case, because 5 people are coming in with 5, the question is, well, what's the probability that each of them will get a jacket? Well, it's 1, because there are only 5 people to give out 5 jackets to. But in a case where each of them will get their own, that's when you add that thing. But obviously, if you want to make it a little more complicated, you can then say, now you're asking, what's the probability that at least one of them got their jacket,
Yeah.
right? What's the
What's
probability?
this probability?
I have no idea.
That wait, no, we can think. What's the probability that at least one got his jacket? What that means is, what's the probability that 1 minus no one got their jacket? Is basically what you're saying,
Yeah.
right?
Yep.
So what's the probability that no one gets their jacket?
That's still kind of hard to...
What's the probability?
Because there are a lot of options,
that
right?
no one gets their jacket. So in this case, each individual, again, you can just count, because these are all just counting things. Like, there are only 5 people here. So in this case, what's the probability that none of them get their own jackets? So person A, one of his jackets,
Oh, then there's a 1 out of...
would it just be 1
There's
minus?
there's a 3 out of 5, or 4 out of 5
Oh, it would just be 1 minus, right? Because 4 out of 5 that he won't get his jacket.
Yeah.
Oh, yeah, exactly. You're right. No, exactly. You're right. So it's a 4 out of 5 that he won't get his jacket, right? And then for the other dude, it would be a 1 over 4 that he would. So it would be a 3 out. So it would be a 3 out of 4, and then it would just.
Well,
it
wait.
would just, so it'll be so it'll be 4 factorial over 5 factorial. So it'll be 1 over 5.
Well, hold on a second. If the first person picks the second person's jacket,
Oh, then that blocks off the whole rest, right?
it changes
Yeah.
the likelihood that the second person can get their own
Yeah.
jacket, right?
Yeah, because if I pick your jacket, then the probability that you get your jacket is 0. And if you pick the next person's jacket, then the next person has a probability of 0 of picking their own jacket. So it changes. This is kind of complicated.
It is complicated.
Yeah.
This is in a topic that we would call a derangement. So I was just showing, like, if I picked 5 different numbered cards and then I like shuffle them around, I'm asking, what's the probability? The shuffling is like that people are going to randomly pick a jacket. What's the probability that the first one is not a 1? Okay, so right away the first person got their own jacket. And the probability that the first one is not a 1, and the second one is not a 2, and the third one is not a 3, and the fourth one is not a 4, and the fifth one is not a 5, all together. So we could write down all 120 ways that there are to arrange 5 things, and then just cancel the ones that have like a 1 in position 1 and a 2 in position 2.
No, but would it not be 1/5 at the end of it, though?
No, it's more complicated.
No, because
Would it be? So it might, like, a lot of things in combinatorics do end up with, it seems very complicated, but then somehow everything cancels out, and there is just the probability that you might expect.
Oh.
Like, I'm pretty sure my thinking was correct. Because, like...
Well, you weren't considering one thing.
No, I know.
Well, we can try. Let's try with smaller numbers.
Yeah.
Yeah, okay. I know. That's always easier.
Like, what if there were 2 people?
What's the probability that at least one of them gets his jacket in this case? So what's the probability?
Oh
that
well,
none of
this
them
is
get their
just
jacket?
this is just 1 out of 2, right? Because there's a 50% chance that you
Yeah.
that you both get your jacket,
Yeah.
and 50% chance that you don't.
Yeah,
So
exactly.
Okay.
Exactly.
What if there were 3 people?
Yeah, and 3 people.
oh, now it's like
It's
there's
a 2/3%. It's a 2/3 that you.
no, it's more than that, because one possibility is that all 3 of you get your jacket,
Yeah.
and then there are 3 possibilities that, like, first person gets his jacket, other 2 don't. Multiply that by 2 because don't
No, but
multiply
you're doing
that
a
by 2
permutation
because
right now. You're just doing a manual permutation. Is what you're doing in your head. You're just doing a 3,
I know, but I think
3 times 2 times 1.
I think it's
Because there's 6 total ways for them to get their jackets. Right? There's 6 total ways for them to get their
I want to hear what you have to say.
Okay, yeah, just continue.
No, I mean, I like this. There's 6 total ways.
Yeah,
So
okay.
let's, you can check them all, right?
So yeah, exactly. That's what I was saying, is that there's one possible way where all 3 get their jackets, and then if all 3, like, now the only other case other than all 3 not getting their jackets is 1 gets their jacket, because if 1 gets their jacket and the other one doesn't, then that automatically means that we're not in the first default case where all of them do get their jackets.
So you're saying you can't have exactly 2 people get their jacket,
Yeah,
and
exactly.
the third one doesn't.
Exactly.
That there's really, like, it seems like there should be 4 cases.
Yeah.
Everybody gets it, all 3,
Yeah.
or 2, or 1, or 0.
Yeah.
But the case of exactly 2 doesn't happen.
No, wait, sorry. That's not what I
If
was...
2 people got their jacket, the third one also gets their jacket.
Yeah, but what I was saying is that either all 3 get their jacket, or the first person gets their jacket, the second person gets their jacket, and the third person... Like, those are 3 separate cases. So there's 4 cases out of 6.
Out of 6 total.
Yeah.
Okay. So you're saying the ones that we care about, everybody gets their jacket back, or 1 person does and 2 other people switched.
Yeah.
And there's 3 ways for that to happen.
Yeah.
You pick the 1 person who gets their own jacket, and then you switch the other 2 people.
Yeah.
So there's 4 options where somebody gets their jacket back out of 6. Does that match with
No.
Wait,
your 1 out of...
Are there 6 ways? There's 1, 2,
Yeah.
3, 4, 5. There's 5 different ways.
How? What do you mean? 3 factorial. You have 3
Then-
people.
Because what I'm thinking about is, like, either they all get their jackets.
So you're thinking
They
about
don't.
it manually, and the problem is you don't have a piece of paper in front of you.
Okay.
That's your problem.
Oh, no,
So-
I mean, I think this is fine.
No,
But,
like,
in the
but
case...
no,
okay,
the
you're
thing is,
saying...
especially with like 3 people, like I guess 3 is okay because there's only 6, but like
Yeah.
you get the 4 and it immediately shoots up, right? So it's gonna
Yeah.
continue to shoot up.
Wait,
So like, you
let's
just-
analyze
yeah.
this one of what are the 5 options. Everybody gets their jackets.
Yeah.
The first person gets theirs and the other 2 don't. The second and the other 2 don't. The third and the other 2 don't. Or no one does.
Yeah.
How many ways can that no one gets their own jacket happen?
Just one way.
No, why?
Why is that?
Because imagine none of them have their jackets. If any two people switch, then one of them is gonna at least get their jacket, right? Is that not true?
That might be true, but why does that make it only one way?
Because if you switch anybody's, then it automatically becomes a case where one of them has their jacket.
Sure.
What if it's the middle? No, because then these guys would just switch and they would have each other's. What if one?
Like if one has two has
there
three,
would
and
only
three
be
has
one way.
one.
There would only be one
If
way.
you switch any two people, then now we're no longer in the case where all three of them don't have their jackets.
So if one has two,
Yeah.
and two has three, and three has one,
Yeah.
that's one way it can happen, right?
Yeah.
But what about this?
Oh,
way?
wait. That's true. That's true. You can just rotate all of them around by one. So there's only two ways then.